You see these AI models making these just incredible leaps in their ability to reason, but have you ever stopped to wonder how that leap actually happens? Well, today, we're going to investigate a real mystery, something right at the heart of artificial intelligence.
Okay, so let's just dive right in. On the left, you've got your standard AI model, a base model, and, well, it completely fumbles a math problem. But on the right, a more advanced thinking model just aces it, laying out all this complex reasoning. So, what's the difference here? What's the secret ingredient?
This whole puzzle has researchers asking a really fundamental question. Are these advanced models learning entirely new skills from scratch, or is something else going on entirely? Let's follow the clues. So first, let's just define our suspects. Base models. They're the foundation. They're trained on these just massive amounts of text from all over the internet. Then you have the thinking models. Think of these as base models that have gone through a special kind of training boot camp. It often involves a technique where the model gets rewarded for good reasoning, kind of like training a pet with treats, and that helps it learn to solve problems way more effectively.
Okay, so a team of researchers from Oxford and Buenos Aires started with this fascinating idea. They thought, hey, what if the base model already knows how to do all that fancy reasoning? Maybe it just doesn't know when to use those skills. Like they're these latent superpowers, just waiting to be unlocked.
So the big question is, how do you even find these hidden skills? All right, let's move on to the investigation and see how they actually peered inside the AI's brain.
Their method was pretty brilliant, actually. They fed a thinking model thousands of problems and recorded all its internal activity. Then they used this powerful algorithm, a sparse autoencoder, which basically acts like a thought sorter. It sifted through all that activity, found the patterns, and grouped similar steps together. And what they ended up with was a map of distinct reasoning skills. A whole taxonomy of thought, with things like verifying a step, planning the next move, or even backtracking from a mistake.
And now we get to the breakthrough. Armed with this incredible map of reasoning skills, the researchers designed a really stunning experiment.
So they took a regular base model, our underperforming suspect, and used the thinking model as a guide. At these key moments in the problem-solving process, the thinking model would give the base model just a tiny nudge in the right direction, basically activating the correct, pre-existing reasoning skill.
And get this, what's so interesting here is how little help it actually needed. On average, only 12% of the entire process required one of these nudges. For the other 88% of the time, the base model was thinking all on its own.
But the result? It was absolutely staggering. This hybrid model, with just that minimal guidance, closed up to 91% of the performance gap with the advanced thinking model. And this was on a really tough, competition-level math test. It could now solve problems it consistently failed before. So the crucial takeaway here is this, that advanced AI training isn't really about teaching models how to reason. It's about teaching them when to use the reasoning skills they already have. The superpowers, it turns out, were there all along, just hidden inside that base model.
Case closed? Well, not quite. This is where we get a crucial plot twist. If an AI can be guided to reason perfectly, can it learn to guide itself?
Yeah, this is the paradox of self-correction. Researchers over at Google DeepMind decided to investigate what happens when you ask a model to check its own work without any external help, a process they call intrinsic self-correction.
And the results, they are so revealing. When the AI gets a hint, an oracle that knows the right answer, its performance actually goes up from 95.5% to 97.5%. But when it's left to its own devices with intrinsic self-correction, the performance gets worse. It drops all the way down to 91.5%. This right here just brilliantly illustrates the problem. When a model tries to fix its own answer, it is literally more likely to change a correct answer into an incorrect one than it is to actually fix a mistake. It just lacks the judgment to know when it's gotten things right. Let's look at a real example. So here, the model correctly calculates that Terry spends $75 over 30 days. Pretty simple, right? But when you ask it to review its work, it gets confused. It completely convinces itself it made a mistake, corrects its own perfectly good logic, and then confidently spits out the wrong answer. So it has the reasoning skills, but it just doesn't know when to trust them.
So what in the world does this all mean for the future of AI? Let's try to connect the dots here.
The takeaway, I think, is pretty clear. We've uncovered a way to unlock these hidden reasoning superpowers in AI, but we've also found a critical weakness. Without a reliable guide, these models can easily reason their way right into a dead end, because they lack the self-awareness to know right from wrong. For anyone using AI, this really means we have to remember that its confidence can be really misleading. The next great leap for AI, it might not be about getting smarter, but about getting wiser.
And that leaves us with a final, kind of provocative thought. If reasoning is just about activating the right skill at the right time, like flipping switches in a circuit, what's the real difference between that and genuine human understanding? Thanks for watching.